Modern air warfare is no longer just about speed, maneuvering, or who has more aircraft in the sky. Today, success depends on who understands the battlefield first, who can see threats earlier, react faster, and share that understanding across an entire force. The F-35A Lightning II was built around that reality. It is not simply a fighter designed to engage enemy aircraft or strike ground targets. It is an aircraft built to operate in complex, heavily defended environments where information, timing, and coordination matter just as much as firepower. In April 2019, two U.S. Air Force F-35A Lightnings flew their first real combat mission over Iraq, striking a hidden tunnel network and weapons cache used by ISIS in the rugged Hamrin Mountains. These jets didn't just deliver bombs. They gathered data, tracked threats, and shared information with other forces to make the entire operation more effective. This was more than a bombing run. It was a demonstration of how modern air power works. Stealth, sensors, data fusion, and precision, all in a single aircraft. Today, we'll walk through how the F-35A actually operates in real wartime conditions, how it prepares, senses danger, navigates defended airspace, and supports the broader fight. Mission preparation. Before the aircraft ever leaves the ground, a significant amount of preparation shapes how it will perform in the air. Mission planning for the F-35 involves intelligence specialists, operations planners, and maintenance crews working together. Updated information about known air defense systems, radar coverage areas, communication networks, and terrain features is compiled and reviewed. This data is then loaded into the aircraft's mission systems. What makes this important is how the F-35 uses that data once airborne. Instead of relying entirely on the pilot to remember threat locations or interpret raw signals, the jet's onboard computers reference this mission data in real time. If the aircraft detects a radar signal or sensor emission that matches known threat types, the system can help classify it quickly. This preparation gives the pilot a starting framework, a digital expectation of the environment, which the aircraft then refines using live sensor input during the mission. A defining feature of the F-35A in wartime operations is its low observable design. The aircraft's shape includes carefully aligned edges and smooth surfaces that help deflect radar waves away from their source rather than directly back. Special materials and coatings are also used to absorb or scatter radar energy. Together, these design choices reduce the range at which enemy radar systems can detect and track the aircraft. During missions in heavily defended airspace, the F-35 carries most of its weapons inside internal bays. This avoids the radar reflections that would come from external pylons and stores. When the bays open briefly to release a weapon, the exposure is minimized and timed carefully within the mission profile. Stealth does not make the aircraft invisible or immune to detection. Instead, it shortens the enemy's reaction time and complicates their ability to build a clear targeting picture. That delay can give the F-35 more freedom to maneuver, observe, or complete its mission before facing significant engagement. At the center of the F-35A's wartime effectiveness is its ability to combine information from many different sources into one coherent view, a process known as sensor fusion. The aircraft's radar can track aircraft and map ground features at long distances. Its infrared systems can detect heat signatures such as aircraft engines or missile launches. Other onboard receivers listen for electronic emissions from radar systems and communications equipment. Each of these sensors provides a different type of information. On older aircraft, pilots might have to interpret separate displays and mentally connect the dots. That takes time and increases workload, especially in high-stress situations.
The DAS detects and tracks threats 360 degrees around the aircraft.
The F-35 can build awareness while remaining harder to detect. On the pilot's display, detected threat systems appear with symbols that indicate type, relative location, and potential danger level. The aircraft's mission software helps evaluate which threats are most significant and may suggest routing adjustments to reduce exposure. The pilot remains responsible for the final decisions, but the aircraft functions like a constantly updating advisor, processing far more data than a human could manage alone and presenting it in a usable way. One of the most important aspects of F-35 operations in war is its role in a networked force. Through secure data links, the aircraft can share its sensor picture with other friendly units. This might include other aircraft, airborne command platforms, or surface forces. The data sharing is designed to be fast and selective, focusing on information that improves situational awareness. This means the F-35 can sometimes detect and track a threat that is not visible to another platform and pass that track along. In doing so, it extends the awareness of the entire formation or task force. Rather than operating as isolated units, modern air forces aim to function as connected systems. The F-35 is built specifically to support that model, acting as both a sensor and a communicator in addition to being a shooter. The F-35A is designed to handle multiple mission types, often within the same sortie. In air-to-air roles, the aircraft uses its radar, passive sensors, and network inputs to track other aircraft and maintain awareness of the airspace. Its systems help manage these tracks and provide the pilot with prioritized information about potential threats or points of interest. In air-to-ground roles, the aircraft's targeting systems help identify and track ground targets with precision. Sensor fusion ensures that targeting data is consistent and supported by multiple sources when possible. The aircraft's computing power helps balance these tasks, allowing the pilot to shift focus as the situation evolves without having to manually manage every sensor mode or system setting. Although the F-35A includes a high degree of automation, the goal is not to remove the pilot from the decision-making process. Instead, automation is used to reduce routine tasks and manage background processes. The aircraft monitors its own systems, coordinates sensor operation, and filters incoming data to reduce clutter. Warnings and alerts are prioritized so that the pilot's attention is drawn first to the most urgent issues. This helps prevent overload in situations where multiple events may occur at once. The design philosophy recognizes that human attention is limited, especially under stress. By handling lower-level tasks, the aircraft allows the pilot to focus on tactics, judgment, and coordination with other forces. After landing, the information gathered during the mission continues to provide value. Recorded sensor data can be reviewed to update intelligence assessments, confirm threat locations, or refine understanding of enemy systems. This contributes to a cycle of learning that improves future mission planning. Maintenance teams also use flight data to assess aircraft performance and system health. This helps ensure that the jet is ready for its next mission and that any issues are identified early. In this way, each flight contributes not only to immediate objectives, but also to a growing knowledge base that supports ongoing operations. In wartime, the F-35A Lightning II operates as an integrated system rather than a single-purpose fighter. Its combination of low observable design, advanced sensors, data fusion, and secure communications allows it to function effectively in environments where information is contested and threats are complex. Its greatest strength lies in how it gathers, processes, and shares knowledge under pressure, helping pilots and commanders make better decisions in less time. And while the technology is advanced, its purpose remains practical and focused. Improve awareness, reduce uncertainty, and support mission success in some of the most demanding conditions modern air forces encounter.